Is the continuation of previous problem. So we will see, yes. So here, as you can see that we got an expression g of j omega, a real term and imaginary terms. So as you can see that in our case there are two poles at the origin, so there should be a bypass. So you should draw the C1. You should find the points due to points of C1. So you should start from omega varying from minus infinity, then 0 minus, then 0 plus, then plus infinity. So now at omega is equal to minus infinity. So when you are substituting minus infinity as omega in your expressions, what happened here is, so you will get here omega square is the infinity square. Here infinity 2 plus 21 plus omega square, that is infinity. So infinity is divided by infinity square. One infinity can be cancelled. So remaining all infinities. So it is certainly minus is the 1 divided by infinity. So it is equal to minus 0. Minus 0. It is equal to minus 0. Then if you are substituting infinity minus j, 2 minus 18. Okay, so this is infinity square. But here what you can see that there is a minus of minus. Yes, so here omega is the, here 1 plus omega square is there, here 1 plus 9 omega square is there. So we are substituting, okay, sorry, yes, okay, minus infinity. So minus infinity means here minus square means it will become plus. Here it is 1 plus 21 omega square, that also plus. Okay, 21 omega square, but here again 1 plus omega square is there. Okay, that is again, so you should analyze it to get the right value. So you should substitute minus infinity in this expression. What happened? So here it is minus infinity 21 omega square. So minus infinity square means, so it will become plus infinity square. Here minus omega square, it become plus infinity square. Or you can take this minus sign as it is. Okay. Okay, so minus sign you can keep it as it is. Omega square, that is again infinity square. 1 plus, this will almost equal to infinity square. This also infinity square. So 1 infinity square will be cancelled. So again you can see minus of 1 divided by infinity square. So it is definitely equal to minus 0. What happened here? Here it is minus infinity square. Okay, so minus j is there. Here 2 minus 18 minus infinity square. So it will become plus infinity square. So minus sign is there. So we will put a minus infinity square divided by omega minus infinity. So that minus and minus will be cancelled here. This minus you forget. So here infinity, here this infinity square cancel. Both are with here minus, here minus. Minus infinity square means infinity square, but there is a minus sign. So this minus sign will be cancelled. But here 1 plus omega square, it again infinity square. Here also 1 plus omega 9 omega square, that is also 1 plus infinity square. So this infinity and infinity squares will cancel. Certainly it will become 1 divided by infinity only. So it is again, you will get a 1 by 0. So you are getting 0. So you should properly analyze it. Okay, please do it. Okay, please do this. Then at omega is equal to 0 minus 0 with a minus sign. Omega is 0 minus, so 0 with a minus sign. So what you have to do is substitute 0 minus sign. So 1 plus term omega square, 0 minus square is 0 only. So this become 0 minus this minus sign, you can put it here. So minus omega square means 0 square, minus 0 means minus will be minus square means plus only. So minus 0 square means it is equal to, yes, like this, minus 0 whole square is equal to plus 0 square, the same way. So minus, this minus you already took. Omega is itself is minus 0. So minus 0 square means plus 0 square plus 1 plus omega square, that is also 1. Here also 1. So 9 omega square is 0. So 1 into 1, 1. 1 into omega square, that is 0. So it is 0. So what you are getting, there is a minus sign. Here it is 1 plus 0. So 1 divided by 0, that is equal to minus infinity. Then what about the next term? When you are substituting here, minus j as it is, 2 minus omega squares, 0 minus sign now plus 0 or minus 0. If you are squaring it, it will become plus only. So 2 minus 0, 2 divided by minus 0. So minus 0 means minus and minus will cancel. So it become plus 1 plus 0, 1 plus 0. So 1 only you get. So you will get a plus some term divided by 0, that is equal to plus j infinity. Plus j infinity. Okay. Plus j infinity. So that is, you are getting here, when omega is equal to minus 0, you are getting minus infinity plus j infinity. This is very crucial. This will decide the shape of Nyquist plot. So you should be very thoroughly, you should take your own time. First time when you are going through, you take your own time to understand this. Okay. So all of you try to do this positively and complete it. Okay, systematically. Now when you are substituting 0 plus, 0 plus. So 0 plus means, okay, here minus sign is there, minus. 0 square means 0. 1 plus 0, 1. 1 plus 0, 1. 1 plus 0. So getting 1 divided, minus sign already you should take it up. So 1 divided by 0 or some term divided by 0. So it is again minus infinity only. What about the next term? Here minus term is there, but omega is plus 0 plus. Okay, here 2 minus 0 square. 0 square means 0. 0 into 18 means 0 only. So it will become 2. 1 plus 0 square, that is 1. 1 plus 0 square, that is also 1 only. 1 into 0, that is 0. Some term divided by 0. Okay, omega is 0 plus. So what happened? This minus term will get. So minus j into term divided by 0. So you are getting minus infinity minus j infinity. Now when omega is equal to plus infinity, you should take this order only. Okay, minus infinity, 0 minus, plus 0, then plus infinity. Okay, now when you are substituting, there is a minus sign here. Okay, minus sign already there. So infinity square. Here also 1 plus some term into infinity, it will become infinity square almost. That will be cancelled. But still here infinity square. So 1 divided by infinity square with a minus sign. So it will become minus 0 only. What about the next step? Minus j as it is you take 2 minus 18 omega square. Omega is minus infinity. So it will become minus, okay, 2 minus 18 omega infinity square. So minus 18 infinity square plus 2. That is nothing but it is almost infinity square only, minus infinity square divided by plus infinity, then plus infinity square, again plus infinity square. So there is a minus and minus will cancel, it will get plus. Okay, so in infinity square, one of the infinity square will cancel. This minus will come here and plus. So plus j, some term divided by infinity. So you are getting plus j 0. So now, in if you are roughly drawing this approximate plot, so when you are this is your q of s plane. Here you are having u, this is jv. Now, yes, as omega moving from minus infinity to minus 0, then plus 0, then plus, that order you have to take it. When omega is equal to minus infinity, g j omega h j omega will get a minus 0 minus j 0. So here, when you are coming here, minus 0 means this side, minus j 0 means it will come to yes. So here minus at you can see that at omega is equal to minus infinity, g j omega h j omega is equal to minus 0 minus j 0. How you can represent that? Minus 0 means this is pure 0, plus 0 means this side, slightly this side, minus 0 means this side. They are only same location only, but little. Minus 0, minus j 0. Minus j 0 means this side plus j 0, this side minus 0. So somewhere like this. This is the point. And next we have to do from minus infinity to minus infinity to 0 minus. 0 minus you will get it. Real axis minus infinity and plus j infinity. So minus from here minus j infinity and plus j infinity. Infinity, j infinity, this is plus j term, okay, jv. This plus j here minus j. So plus j infinity. So minus infinity. So suppose if you are taking this as minus infinity, for example, we cannot represent like that. And this is plus j infinity. If you are to say this is plus j infinity. So suppose you are representing a point here, okay, as minus infinity plus j infinity. So one point is here. So you cannot, it is down to this line. So you cannot simply draw. So what you have to do is you have to take an arc like this and it should go like this. Got it? So you got, and the direction is this way. Direction is this way, and it will reach this point. Try to understand how it is drawn. You cannot do from here, you cannot do it like this because it is below this and this left. So you have to start like this with an arc. Okay. Okay. Now, when omega is equal to 0 plus g j omega h j omega is minus infinity and minus j infinity. So this will be, let us represent that this is minus j infinity. Okay, and here j infinity, this is the point. Okay, and when at omega is equal to plus infinity, you can see that g j omega h omega is equal to minus 0 plus j 0. Minus 0 means this side, plus j 0 means this side. So you will get a point here almost. Means there are same point only, but you know, so when you are doing like that, it is above this line, slightly above this line and this left. So when you are going this, you don't draw a straight line. Instead of that, you can draw like this with the, like this. The angle is like this. Okay. Now, rest of the things, this is only for C1. This is only for C1. Now we have to draw the C2. Okay, C2 what happened, as well as what happened to this epsilon e to the power of j theta. So we get 4 points to draw an approximate Nyquist plot. The infinite is, so we got a somewhat idea how it is, and direction is like this. This is direction is like this. Okay, and here, yes, it is not clear. Now, so we get 4 points on draw the approximate Nyquist plot. The infinitesimally small semicircular arc of the Nyquist contour. This is this arc, figure 8.1, represented by substituting S is equal to epsilon e to the power of j theta, limit epsilon tending to 0, where theta varies from minus 90, 0, plus 90. Theta varies from, where theta varies from minus 90 through 0 degree to plus 90 degree is mapped into. So what you have to do, your expression, wherever S, you have to substitute epsilon e to the power of j theta and limit eta tending to 0. So you are getting an expression like it. Limit eta tending to 0, 6 epsilon e to the power of j theta plus 1, eta square e to the power of j2 theta, then e to the power epsilon e to the power of j theta plus 1, 3 epsilon e to the power of j theta plus 1. Wherever S you should replace by eta into e to the power of j theta in your open loop transfer function. So, okay, we did like that. So we got an expression like this. Now, when eta tending to 0, 1 plus 0, eta is there. So this becomes 0, this entire time becomes 0. 1 plus 0 means 1. And here, we'll forget about this. What happened here? 1 plus eta is there. So this also become 0, 1 plus 0. Here also eta is there. This also becomes 0. So 1 plus 0. 1 into 1, 1. So you are getting, finally, you get 1 divided by limit of epsilon tending to 0. Not eta, okay. Sorry. Epsilon tending to 0. Okay. Epsilon okay, epsilon tending to 0. So here epsilon is there, so this becomes 0. 1 plus 0. Forget out this. Here 1 plus epsilon term is there, so this is 0. 1 plus this also becomes 0. So 1 into 1 multiplied by this. So you are getting 1 divided by epsilon square e to the power of j 2 theta. Now this 2 theta can be taken above. So that means e to the power of minus j 2 theta, and epsilon tending to 0, 1 by epsilon square, 1 divided by 0 is equal to infinity. So you will get an infinity of from e to the power of minus j 2 theta. Theta is, okay, so you are getting infinity now infinity e to the power of minus j 2 theta. Focusing problem. Okay. So this way you are getting it. So here theta varies from minus 90 to 0 to plus 90. Now if you are 2 theta, minus 2 theta means minus 2 into minus 90. Minus of minus plus, so it will become plus 90. This will be, no, plus 180. 2 into 90, 180. Theta means 0 means 2 theta minus sign also it will become 2, 0. Then theta is plus 90. Minus of 2 into 90, that is minus 180. So this way, plus 182 to 0 to minus 180. The if you are mapping this portion to your plot, this is the previous problem, but we will see our diagram how it is. But same thing, when you are mapping this arc, to Nyquist plot, what you are getting is, in our problem, it is amplitude is infinite, and it is from minus 180 to plus 180 to minus 180. So when you are taking this, already we drawn like this only, or Nyquist plot. Nyquist plot we already done like this. So what is plus 180 degree? Plus 180 degree means this is plus 180 degree. Am I right? This is plus 180 degree. And what is minus 180 degree? This is minus 180 degree. So it will start from plus 180 degree to 0 to minus 180 degree. So amplitude is infinity. Now you have to take the intersection of already we drawn something plus this. So when you are drawing like that, this is infinity only, it will go through infinity, and here also it will go through infinity. Amplitude is infinite, magnitude is infinity, and it will come. This is for that small arc, you have to remember that. So like this, and direction is this way. So it is from plus 180 to 0 to minus 180. So arrow is, you will get automatically, you will get everything, will be automatically you will get. See now, when you are observing it, the arrow is coming like this, it will go like this, it will come like this, like this, like this, like this, like this, like this. So it is very interesting to understand this. Okay, now we did only this. Now we have to do this C2. For C2, the infinite semicircle of Nyquist-Kondo of figure A32 represented by, what you have to do for this? You have to substitute S as R into e to the power of j pi, where R tending to infinity in your basic expressions. Okay, and here very carefully you see that pi varies from plus 90 to 0 to minus 90. The angle representation like that. So what you need to do is, so you have to substitute in your expressions. Wherever S, you should substitute R into e to the power of j pi. So you're getting limit R tending to infinity 6R e to the power of j pi plus 1. Then wherever, there it is S square. So R square e to the power of j 2 pi. Then 1 plus S plus 1. So R into e to the power of j pi plus 1. Then 3S, 3R into e to the power of j pi plus 1. Now, when R tending to infinity, what happened? R tending to infinity, this we cannot cancel. You have to keep as it is. Okay, so here this also we cannot cancel. This all are tending to infinity. So what you have to do? Infinity plus 1, you can keep it as this term only. R tending to infinity, no? This is big term. R 6R into R tending to infinity. The plus 1 means you have to keep this term only. Here also this term only. Plus 1 is nothing more, no effect at all. So plus 1 you can eliminate. So R into e to the power of j pi. Yes, 3 into R into e to the power of j pi plus 1 is equal to 3 into R into e to the power of j pi, because this is an infinite term. If you are adding 1, nothing will change. So now denominator, if you are multiplying, R square e to the power of j 2 pi multiplied by R into e to the power of j 2 pi multiplied by 3 R e to the power of j 2 pi, you will get 3 R square R. So R raised to 4. Here e to the power of j 2 pi, e to the power of pi, e to the power of j pi. So you will get e to the power of j 4 pi. Now numerator 6R e to the power of j pi. So here whatever you can cancel it. 6 divided by 3, you will get a 2. R will cancel, so 1 R will go. So R to the power of 3. E to the power of j pi divided by e to the power of j 4 pi, so it becomes e to the power of j 3 pi. Now here R tending to infinity. So now this e to the power of j 3 pi, you can take it to numerator as e to the power of minus j 2 pi, 3 pi, some term divided by R raised to 3. And R tending to infinity. That means this will be infinity. Some term divided by infinity will be 0. So 3 pi minus 3 pi. So you are getting 0 into e to the power of 0 into e to the power of minus j 3 pi, and pi varies from plus 90 to 0 to minus 90. So when you are substituting this into the exponent, plus 90, what is magnitude is 0. If you are putting the 90 to this, or pi by 2, 3 into 90 means minus 270, 2 minus 272, 0 to plus, if you are minus 90, if you are substituting, it will become plus 270. So that is how you are getting minus 270 means here 0, when you are doing that, this will come like this, somewhere here, minus 270. Okay, and it will give a magnitude of 0 from minus 270 to minus 270 to 0 to plus 270. Plus 270 will come somewhere here. So the magnitude is 0. So when you are adding 0 to this will only. So it won't have any effect. Okay, so you got like this. Now we need to find this point. How you can find this point? Point of intersection of the Nyquist plot on the real axis. Then only we can see that whether this will be minus 1 plus j minus 1 plus j0 is within this circle. That you have to see that. For that, what you need to do is, so here the point of intersection of Nyquist plot on the real axis is obtained by equating the imaginary part to 0. This is the imaginary part. This is the imaginary part to 0. Means when there is a point here, its imaginary term is 0. So what you can do is, imaginary part of your expression you have to equate to 0. That is 2 minus 18 omega square divided by omega into 1 plus omega square into 1 plus 9 omega square, you are equating to 0. So when you are equating to this 0, that will become 2 minus 18 omega square is equal to 0. Okay. Now this will close variable, already it becomes 0. So 2 minus 18 omega square is equal to 0. From that, omega square is equal to 1 by 9. So omega is equal to 1 by 3 radians per second. Now the value of g j omega h omega at omega 1 by 3 is obtained by substituting this value of omega in the real part of j omega h j omega. So here we got omega value. So you should substitute that omega value to the real part to understand the exact value on the real intersection of Nyquist plot by. Okay, so when you are doing like that, so you should substitute omega. This is the 1 plus 21 omega square divided by minus omega square, 1 plus omega square plus 1 plus 9 omega square. Okay, there you substitute omega as 1 by 3. So 21 divided by omega square, 1 by 3 means 1 by 9. So 21 divided by 9 divided by minus 1 by 9 omega square, then 1 plus 1 by 9, 1 plus 9 by 9. So when you are getting it, you will get this will become 1 plus 1, 2. Yes. Yeah. This is 1 minus 9. So here you have to take a common term. 9, yeah, 1 plus 21, 1 into 9, 9, 9 plus 21 divided by 9. So 30 divided by 9, numerator. And denominator, 1 plus 1, 9. So 9 plus 1, that is 10 divided by 9. This is 9 plus 9. Yeah. That is 2. Here you are getting 2 into yes. So when you are doing like this, what you are getting? You will get we'll see that 1 plus 21 divided by 9 divided by minus 1 by 9 into 1 plus 1 by 9 into 1 plus 9 by 9. So you are getting it as, here you are getting it as 30 by 9 divided by, this is minus 1 by 9 multiplied by, here you will get a 10 by 9 into 2. 2. So 2 can be represented as 18 by or 18 by 2. So here when you are doing like that, 1 9 and 9 can be cancelled. So here you will get it as minus 30 divided by minus 30 divided by this minus you will take it as minus 30 divided by 10 into 2. 10 into 2, yes, 10 into 2, 20. So this 9 will go to here. So you will get a minus 3 into minus 27 0 divided by 20. So it is equal to that minus 13.5. Minus 13.5. So you are getting it as minus 13 point. So this point is 13.5. Omega is 13 point. So certainly it is within the minus 1 plus J0. But for the stability, you should have a counterclockwise. But here you can see it is a clockwise. So we will see that based on the above information at a minus 30. Based on above informations, the approximate Nyquist plot is drawn with the Nyquist path shown in figure, as shown in figure. From this plot, we can observe that the Nyquist plot of g of s h of s encircles the minus 1 plus j0 point twice on a clockwise directions. But actually for stability it should be therefore n is equal to minus 2. This given open loop transfer function g of s h of s has no poles in the right half of s plane. So p is equal to 0 because there is no counterclockwise rotation. Thus minus 2 is equal to 0 minus z. So z is equal to 2. Hence 2 zeros on q of s lie on the right half of the s plane. So the closed loop system is unstable.